Hey everyone, today I would like to discuss for your understanding the principles of basic electricity and electrical circuits. And our learning objectives for today's topic is for you to be able to describe the parts of an atom, explain the importance of the number of electrons on the valence ring of an atom, describe how electrons flow through a conductor, define conductor, semiconductor, and insulator, explain voltage, amperes, and ohms in an electric circuit, explain how a voltage drop test works, describe the main features of a series circuit, and explain the factors that determine the strength of an electromagnet. An understanding of basic electricity is absolutely essential before a study of more complex electrical electronic systems. It is very difficult to understand electrical electronic systems if you don't have a clear understanding of basic electricity. If you are familiar with the principles of basic electricity and how they apply to the operation of electrical electronic systems, then the understanding of these systems becomes much easier. An atom may be defined as the smallest particle of an element in which all the chemical characteristics of the element are present. Atoms are very small particles that cannot be seen even with a powerful electron microscope that magnifies millions of times. Atoms contain even smaller particles called protons, neutrons, and electrons. Protons and neutrons are located at the center or nucleus of each atom. Protons contain a positive electrical charge, and neutrons add weight to the atom. Heavier elements contain more neutrons. So all electricity is really the measurement of the flow of electrons or current from one atom to the next. Electrons circle around the nucleus or center of the atom in various orbits. For example, a hydrogen atom contains one proton in the nucleus and one electron orbiting around the proton. The hydrogen atom does not have any neutrons. A copper atom has four orbits or rings with 2, 8, 18, and one electron on these orbits. Atoms may have from 1 to 7 orbits with different numbers of electrons on each orbit. Electrons have a negative electrical charge. Elements are listed in the periodic table according to their number of protons and electrons. For example, hydrogen is number 1 on this scale, and copper is number 29. The nucleus does not have the same number of protons and neutrons. A copper atom has 29 protons and 35 neutrons. The outer orbit on an atom is called the valence ring. The number of electrons on the valence ring determines the electrical characteristics of the element. If the valence ring has 1, 2, or 3 electrons, the element is classified as a good conductor because the electrons on the valence ring move easily from an atom to another. And good example of the conductors are copper, gold, water, graphite, and all other metals. When an atom has 4 valence electrons, it is classified as a semiconductors. Semiconductors have special electrical characteristics. The characteristics that makes semiconductors special is the ability to be a conductor at certain times and an insulator at others. This is generally determined by the amount of energy applied to it. This energy can be in the form of heat or voltage. These materials are used to manufacture diodes, transistors, and carbon fiber spark plug wires. If an element has 5 or more valence electrons, these electrons will not move easily, and the element is classified as an insulator. And the examples of insulators are glass, plastic, ceramic, rubber, wood, fabric, wool, cork, paper. If an atom has the same number of protons and electrons, the atom is in balance. Atoms always try to maintain their proper balance with the same number of electrons and protons. If an atom loses an electron, it will try to attract an electron from another atom. When an atom has more protons than electrons, it is unbalanced, and the positively charged protons will immediately attract other electrons from another atom. An element is a material with only one type of atom. For example, pure copper contains only copper atoms. A compound is a material containing 2 or more types of atoms. For example, water, H2O, contains hydrogen and oxygen. A molecule is the smallest particle of a compound that retains all the characteristics of the compound. A massing of electrons must occur at one point in an electric circuit, and a lack of electrons must be present at another point in the circuit before electrons will move through the circuit. The massing of electrons may be referred to as electrical pressure. The electrical circuit must also be complete between the massing of electrons and the lack of electrons. When these requirements are present in a circuit, the electrons begin moving from the massing of electrons into the atoms in the conductor. If an atom has more electrons than the protons, it immediately repels an electron to another atom. When an atom lacks an electron, it attracts the electron from another atom. Current flow may be defined as the mass movement of valence electrons from atom to atom in a conductor. Voltage is the electrical pressure caused by a massing of electrons at one point in an electrical circuit. So a good analogy for voltage is the hydraulic systems, where you have the hydraulic fluid as the current, and the PSI, the pressure, or the pounds per square inch or bar, is the voltage, because the pressure is the pusher and the voltage is the pressure that pushes the electrons or the current from moving from one point to another. Voltage is a measurement for electrical pressure difference. So voltage is the energy that is applied to an atom to force it to move its valence electrons. So without this pressure, these electrons would not move to any degree necessary to be useful. So if a voltmeter is connected across the terminals of an automotive battery, the voltmeter may indicate 12.6 volts if the battery is fully charged. This reading indicates there are 12.6 volts at one battery terminal in relation to 0 volts at the opposite battery terminal. Amperes is a measurement for the rate of electron flow or the amount of current flow through a circuit. The AH, or the ampere hour, is the rating. So is the amount of energy charge in a battery that enables 1 ampere of current to flow for 1 hour, or you can also say that AH is the rating indicating how much amperage a battery can provide for 1 hour. So amperes will continue to flow through a circuit as long as the massing of electrons and lack of electrons are maintained in the circuit. There are two theories regarding the direction of electron movement of current flow. The electron theory says that electrons are negatively charged and electrons move from a massing of electrons, negative charges, to a lack of electrons, positive charges. The conventional theory says that for illustration purposes in the automotive industry, we assume that current flows from positive to negative through a circuit. Excessive amounts of electrons or the amperes flowing through a conductor will cause heat buildup. This in turn will raise the resistance in the conductor and drop the voltage in the conductor. This action will force the circuit to increase the electrons flowing to maintain the circuit, thereby increasing the heat. This cycle can happen very quickly with devastating results to wiring and electrical components if the right size and type of conductor is not used. So amperes is a measurement of electron or current movement through a circuit. If a 1 ampere of current is flowing through a circuit, 6.25 billion electrons are passing a given point in the circuit in 1 second. Direct current or DC flows in only one direction. Most automotive circuits operate on direct current. An alternating current or AC flows alternately in one direction and then in the opposite direction. The windings in the alternator stator have AC flowing in them, but this AC is rectified to DC by the diodes in the alternator. Therefore, DC is delivered from the alternator to the battery and electrical components on the vehicle. Electrical resistance may be considered the opposition to electron movement in a circuit, and this resistance is measured in ohms. The size, length, type, and temperature of a conductor determines its resistance. For example, a smaller diameter wire has a higher resistance to electron movement compared to a large diameter wire. Material is another significant contributor to a resistance both positively and adversely. Copper is an excellent conductive material with low resistance. However, oxygen is a poor conductor with high resistance. Ohm's law states that it takes 1 volt to move 1 ampere with 1 ohm of resistance. So in order for oxygen to conduct electricity, the voltage required to force it to conduct must be very high, in the thousands of volts to conduct across a spark plug gap to the millions for a bolt of lightning to strike dirt. When metals combine with oxygen, we get oxides like iron oxide or rust, to aluminum oxide or corrosion. These combined materials are also poor conductors and will add resistance to any circuit they are in, reducing efficiency or stopping the flow of electrons if enough is present. What is an electrical measurement that is calculated by multiplying the amperes by the volts? Although watts are not measured when servicing vehicles, it plays an important role in electrical system design. For example, if the total amperage load of all the electrical accessories on a vehicle is 250 amperes in a 12-volt electrical system, the total watts of an energy required are 12 volts multiplied by 250 amperes equals to 3,000 watts. Therefore, the charging circuit on the vehicle must be capable of supplying over 3,000 watts. Ohm's law states that the current flow in a circuit is directly proportional to the voltage and inversely proportional to the resistance. This indicates that an increase in voltage causes a corresponding increase in current flow, whereas a decrease in voltage reduces current flow. Conversely, an increase in resistance decreases current flow, and a decrease in the resistance increases current flow. Ohm's law may be used to calculate a value in a circuit if the other two values are known. In this formula, voltage is indicated by V. Amperes is represented by A, and R indicates resistance. So if 12 volts are supplied to a circuit and the resistance in the circuit is 2 ohms, the current flow is 12 volts divided by 2 ohms equals 6 amperes. When a circuit has 4 amperes and 3 ohms resistance, the voltage is 4 amperes multiplied by 3 ohms equals to 12 volts. If a circuit has 12 volts and current flow of 1.5 amperes, then resistance is 12 volts divided by 1.5 amperes equals to 8 ohms. Voltage drop is the difference in voltage across a resistance when current flows through the resistance. There is always some voltage drop when current flows through a resistance. For example, less than 0.05 volt drop across most switch contact is normal. However, higher than normal resistance causes high voltage drop in a circuit. High resistance and high voltage drop result in reduced current flow in a circuit. When a set of switch contacts becomes pitted and corroded, they may have a 2-volt drop, which reduces current flow in the circuit. This voltage loss is caused by the high resistance and the corrosion. The high resistance allows the contacts to act like another load in the circuit, the same as if you added additional components to a circuit to the point it ceases to function correctly. In a series circuit, the same current flows through all the resistances in the circuit. A series circuit has these features like number one, the same current flows through all the loads and the circuit because there is only one path for current flow. The next one is the total resistance is the sum of all resistances in the circuit. The third one is the voltage drop across each load depends on the ohm value of that resistance. And the last one is the sum of the voltage drop across each load equals the source of voltage. So the heater blower circuit is an example of a series circuit. The resistors in the blower circuit that control blower speed are switched in a series with the blower motor. By adding resistance, the motor will slow down because it receives less voltage as the resistance is increased. In a parallel circuit, each resistance is a separate path for current flow. These facts may be summarized regarding parallel circuits. Each load has a separate path for current flow. The amount of current flow through each load depends on the amount of resistance in that part of the circuit. Equal full source voltage is supplied to each load and equal force source voltage is dropped across each load. The total resistance is always less than the ohm value of the lowest resistor in the circuit. So the light circuit in a vehicle is an example of a parallel circuit. Each of the light is connected in parallel to the battery, so it gets the full battery voltage. In a series parallel circuit, a component is connected in a series with a parallel circuit. Many automotive electrical circuits are series parallel circuits. For example, the instrument panel lights are connected parallel to the battery, but the variable resistor that dims the instrument panel lights is connected in a series with these lights. Electromagnets. A permanent magnet has an invisible magnetic field surrounding the magnet. These lines of force move from the north pole of the magnet to the south pole. One of the basic magnetic principles is that like magnetic poles repel each other, and unlike magnetic poles have an attracting force. This principle is used in a starting motor. An electromagnet is manufactured by winding a coil of wire around a metal core. When current flows through a straight wire, a magnetic field surrounds the wire. This magnetic field is concentric to the wire and the same strength at any point along the wire. In the coil of wire on an electromagnet, the magnetic strength of each loop of wire adds to the strength of the other loops, and the magnetic field surrounds the entire coil. An iron core placed in the center of the coil helps to concentrate the magnetic field because iron is a better conductor for magnetic lines of force compared to air. The strength of an electromagnet is determined by the number of turns on the coil and the amount of current flow through the coil. Increasing either of these factors provides a stronger magnetic field around the electromagnet. The magnetic strength is calculated by multiplying the amperes by the number of turns. For example, 1 amperes multiplied by 1,000 turns equals to 1,000 ampere turns. The electromagnets are used in relays and solenoids. If the current flow through the coil is reversed, the polarity of the coil is also reversed. When a conductor is moved through a magnetic field, a voltage is induced in the conductor. This process is called electromagnetic induction. If the conductor is connected to a complete circuit, current flows through the circuit. So during the electromagnetic induction, it doesn't matter if the conductor is moved through a magnetic field or the magnetic field is moved across the conductor. Voltage is induced in the conductor. During the electromagnetic induction, the amount of voltage induced in the conductor is determined by these four factors. One, the number of conductors. Two, the strength of the magnetic field. Three, the angle at which the field crosses the conductor. A 90-degree angle is optimum. And the last one is the speed of motion. So in an alternator, the revolving magnetic field of the rotor cuts across the stator windings and induces voltage in these windings. This voltage supplies current to the battery and electrical accessories in the vehicle. In an ignition coil, the windings are stationary and the magnetic field moves across these windings to induce voltage in the windings. This voltage is used to fire the spark plugs. Induction is generally wanted. However, in certain cases, it can be harmful. For instance, if high voltage spark plug wires are allowed too close when one wire is fired, current can be induced in another that is too close. This can cause a poor running engine at best and damage at its worst. To prevent this, manufacturers always space wires a certain distance in retainers or clips and will also turn some at right angles if one wire must cross another. So after magnetic lines of force pass through a piece of hard steel, the steel retains magnetism. After magnetic lines of force pass through a piece of soft iron, it becomes demagnetized immediately. So this is it for our today's topics. I hope you learned these topics for today, and we already have the principles on basic electricity, so that we'll uh, be able to learn some other electrical components in the vehicle. So thanks for watching.